And welcome to episode of the Gaslec Podcast. And thank you very much indeed for listening and for watching on Spotify and on YouTube as well. In this week's episode, we're going to be going through some of our listeners and our viewers' questions. And we're going to explain a couple of fixtures and fittings that we use, like a TMV and pressure reducing valves as well that we use on plumbing. But first of all, here's my friend Sean to tell you a bit more about the podcast. Are you a new person coming into plumbing and heating? Are you a homeowner that likes a bit of DIY? Or are you a business owner and wanted a bit more knowledge before you make some decisions on your plumbing and heating? Stay tuned to the podcast and hopefully we'll be able to help you out with some of your questions. And welcome back and thank you very much. We've had, I put out on social media a couple of little posts. We're on a few little groups for sort of apprentices and stuff like that. So I put out some questions and this is really sort of for our DIYers out there. So one of the questions we got in on email was, why do my radiators are cold at the bottom? So there's a couple of reasons for it. And before everyone starts shouting out, it's sludge, it's this, it's that. First thing you need to check is, when are you checking for this cold at the bottom, hot at the top sort of scenario? So heat will rise in water and that's a constant and a given. So what we need to be mindful of, if we've just turned on the heating system and it's starting to run, that we give it a good 30 minutes, 45 minutes before we sort of come to that conclusion. If it's been on for, let's say, an hour, all depends how big your system is, your boiler, and your property, how cold the water is, how quick it's heating up, etc., etc. There's quite a few factors involved. But if we get a bit of an idea of that, after an hour, let's just say, we're still cold at the bottom and hot at the top, is the valves open widely? So if we're restricting down the flow, now there's two valves on a traditional radiator. We've got the lock shield valve, which is our sort of our flow reducing valve. And then we may have another valve, the same idea as the lock shield, or we may have a thermostat mixer valve or a thermostat sort of setting valve on the side. That's typically your frost 0, 1, 2, 3, 4, 5, the little rotary hand operated valve on the side. So if we do have that, and certainly as we come into the autumn, if we've got that, make sure that the thermostat valve is all the way open. And the pipes on the bottom, what I tend to do is I tend to touch and hold them and see what the temperature's like. Now, after an hour of your heating system being on, and let's say all things were being well and good, nothing's really changed. It's not a brand new install. You haven't had any other works done and nothing's been touched since the last time it was working back in the winter. If you touch both of the radiator pipes at the bottom and now getting on for roughly the same temperature just by your hands, really, without being too scientific. If they're both the same temperature roughly, or near as damn it, then the water is flowing through the radiator and out the other side and it's reaching that temperature. And then there's a good chance at that point, I would say it was sludge. If you're touching the radiator and it's warm on one side or hot on one side and sort of best part tepid or cold on the other, you're not getting the heating. The water isn't flowing through the radiator and you've got to get that running before you jump to. Now, we do power flushing here and cleaning heating systems, and it is labour intensive. It's a big costly machine. We have to use loads of water, loads of chemicals to do it. So it's not a cheap process of getting it done. So before you go and commit to that sort of cost, just make sure your valves are open. Now on the TRVs, I should have got one here, I didn't think about it really, they have a little pin on them. So if you do unscrew the top of the TRV, so generally speaking, anything in plumbing, if you can do it by hand with your fingers, then it's not going to leak everywhere by design. Now, if it's gone faulty, it's gone faulty, and there may be a gland issue that's leaking. But if you can get your fingers and undo something, typically it's an adjuster that you can do yourself as the homeowner, and you shouldn't get wet. So what happens is on the TRVs, if they've been pushed down all summer, and when it comes to winter, these little metal posts, I'll do that on the next episode of the podcast, they get stuck down. And so we can free those up, either give the fitting a little tap on the side. I think I've done a video on this before, or give the pin a little gentle pull to make sure it's going up and down. And that'll make sure that that valve is open for you. If not, the lock shield on the other side on the way in, just make sure that's open. But you might need a spanner to undo that. And that's a normal right-handed thread, lefty loosey, righty tighty type stuff. And just to make sure that's flowing. So there's a couple of things you can check there before you go into booking up power flushes and system cleans. But if you do that there, you can give that information to the person on the phone. Down here in Kent, obviously we do it here at Gaslec, but if you're somewhere in the country or somewhere in the world, give your local plumber, heating engineers a call and they'll be able to assist you there. So the next question we've got is, how do I increase my shower pressure? So we've got a couple of things here. So I was going through a bit of a conversation with someone in the week about flow and pressure and what the difference is between the two. So flow and pressure. So a flow is like speed, and your pressure is the energy behind the speed. So let's say we've got a fly flying at 10 mile an hour and it hits you square in the middle of the head. Okay, a little blue bottle. And it's not going to be comfortable, it's going to be a bit horrible, but 10 mile an hour fly hits you. Or a 10 mile an hour lorry hits you. Now they're both going at the same speed, the same flow, but the pressure behind the two is completely different. One's going to be an inconvenience, and the other one may see you seeing if there is an afterlife and there is a heaven or whichever you believe in. So that's the difference between your flow and pressure. So when people say, I want to increase the pressure on my shower, does that mean that typically in the shower you've got loads and loads of flow, but you put your thumb on it and it'll stop? Ultimately, that's what it is if you've got loads of pressure and loads of flow and no pressure, which don't generally happen. So when you say about shower pressure, you normally mean about shower flow. Now, your flow rate is all determined by a few factors, and it all depends on your hot water system that you're using. If you've got a system where you've got the tanks in the loft and you've got the hot water cylinder in your cupboard, like the big old copper cylinder with a little jacket around it, that sort of system there, you've got what's called a gravity system. Because you're storing the water up, you can pump the water. So you can then fit, there's a few factors involved, but you can fit a shower pump, and that will then give you an increased pressure, give you an increased flow rate into your hot water system. And we've always got to think about balancing between the two. I'm going to go through something in a bit about the balancing side, but we've got to make sure that the two flow, the pressures coming into the shower are roughly of equal pressure. Because if you get an imbalance, you can get a bit of fighting that's going on, and that will take away all the technology, and all that investment into your system will be gone. So there is that pressure. Now, there is that system. If you're on a combination boiler, which is probably the most common nowadays, combination system, and you want to increase your flow rate into your shower, your best part snookered, unless it is absolutely really poor, dribbling out the end, then you're sort of stuck a little bit, really, because of the way combination boilers work. They heat the water as it's passing through, and it can only do it at a certain speed and flow rate. So typically what our combination boiler will work on hot water is it will be typically 35 to 40 degree rise of cold incoming temperature at a flow rate. So a 30 kilowatt boiler, rule of thumb is about 12 to 13 litres a minute. So your 30 kilowatt boiler at your 12 to 13 litres. And if your cold water's coming in here at, say, 10 degrees, you'll have a 40 degree rise on like your Valent, so that will give you 50 degree hot water. Now, if that temperature rises, now I did have a call from a good friend of ours here at Gaslec, and she was saying that the hot water's far too hot, there must be something wrong with the boiler. It was on the hottest day of the year when the cold water temperature was almost 24 degrees in coming to the house. So the pavements are hot, the ground's hot, the front garden's hot, and it's heating up the hot water as it's coming through. So our 24 degrees plus our 40 degrees on our Worcester boiler, well, that's given us some very, very hot water. But when we're coming into the depths of winter, when the water coming in, say, 5 degrees, and when we have 40 degrees, that's 45 degree rise of temperature of water. Now we're starting to get to a point where we can almost bathe in that water. That's like a really hot bath, 45 degrees water. Remember, when you pour it through, it's going to start cooling down because the surface area of a bath's going to be cold. Is large, it's going to help the cooling. So you're going to almost have a 100% hot water bath out of that because it's not going to maintain 45 degrees. But what I'm getting at is that when you're having a shower and you've got the air that's around the shower as the droplets are forming, you do lose a lot of heat in that situation. So it all depends on how. Now, going back to it, on a combi boiler, you're at your 12 litres, 13 litres a minute. Now, if you exceed that, then you see the temperature difference between the 40 degree rise starts to drop because basically the boiler can't keep up. We're demanding too much water all at the same time. It's coming through too fast. It can't heat it up quick enough as it's passing through the plate heat exchanger. So now we're exceeding the specification and the limits of the boiler. And we've had this call out before from customers saying about their boilers not working correctly. And it always happens in the winter because of this incoming cold temperature. And that's the truth behind it. And we go out there and we set we've got a new digital system that we've got now, but we can set your flow rate and we'll set that at 12 to 13 litres a minute on your 30 kilowatt boiler. And then we run the cold. We then see what the cold temperature is, turn that off at the kitchen tap, we turn the hot on, and then we'll then set the flow temperature. We can set the flow rate. It's on the display. I'll do a lovely video on that one day. Set the flow rate. There it is flowing through, and that's then your temperature difference and your rise, and then that then improves the operation of the boiler. Now you will lose efficiencies with a bit of rubbish inside the plate heat exchangers over the years, but ultimately there we are. And typically out of the box, they're a little bit over-spec'd, actually. Let the truth be known. If they say 40 degree rise, I've seen sort of 43, 44 degree rise of temperature at their thing. But that will obviously sort of diminish a little bit with a bit of age. So hopefully that has helped answer that question. So the next question is, why does my WC keep running? WC, as we all know, we call it a toilet, but it's actually a water closet. When it was invented, it was a high-level toilet. Do you remember the ones that were really up high? And so it would give you the good flow coming down that flush pipe straight into the toilet. And going back then, because the water was so high with gravity dropping down, we never got blocked toilets, did we? All gone close coupled, all gone eco, reduced flushes and all the rest of it. And all of a sudden, we're not. But I think those big ones were running at sort of 10, 12 litres of a flush water. One, where we had a little tiddle in it, where we done something else in there, it'd have one delivery of water all at the same time, a proper good flush. Any road. Most people don't have those high-level toilets anymore. And we've got these little close coupled systems. So I had a little look downstairs and I found in an old box, this one's been kicking around in a van for ages by the look of it. It don't look great at all, does it? So we won't be fitting this at our customers. But this is typically a bottom entry, because obviously it comes in here, so the water will come in from the bottom of the system, a bottom entry toilet fill, we call these. So the most common problem we get is when the toilet is now overflowing. So modern toilets will overflow into the bowl. Older toilets will outflow through an overflow pipe that goes out from the side. Now, if you've got one of these little fellas here, and basically the way it works is the water comes in at the bottom, and this one's got a brass fitting, which is great. I hate the plastic ones. Comes in here, and basically we've got a float. And as the water level comes up, and this is just a little float of air, it comes up and it moves this top armature. And it's a tiny little pinhole almost of water. So when the toilet fills up, have you noticed how it fills up quite slowly compared to opening up a tap? So we have full mains coming to here. Sometimes there's flow restrictors into the bottom if you're running on cold mains. If you're running on a gravity tanked cold water system, you'd pull those out to increase the water flow. So then under this little cap here, if I can get this off without cutting my fingers, and then I don't know if you can see it, that little armature goes up and down in there and basically pushes down a pin, and then the water just drops out the side nice and slowly. So the way you test these really is you just lift that up, and sometimes there's a bit of a delay on them, but you just lift that up and hold it with your toilet, and if all that water around here somewhere, wherever it's coming from, stops, then you know that's not your problem. And it's on the flush part, which is typically, it'll be on a push button type, it'll be a rise up and it'll have a little rubber seal on it. and drops down. Now, they're typically quite reliable, but there is a little piece of rubber on the bottom that can get a bit old and perished. But if you lift this up and it doesn't stop, then you know this is your issue here. To change them over is quite straightforward. Obviously, it'll isolate the water. As soon as you start undoing this nut here on the bottom, any water that's left in the bottom of the system will obviously want to exit and come out as well. So to slide these in, then we've got this little adjuster screw here, and then that gives us, how does this one work? This gives us the opportunity, I should have practiced this before, it'll either go up and down. It's not playing ball at all. Maybe that's why we haven't fitted it. And then to fine tune it, we can just come off of here. It's a little bit prehistoric, but as we then adjust that there, that will then fine tune this float here for the correct level of water that we want and need. So getting these changed over is quite straightforward. Just remember, if the toilet system is wet, silicone doesn't stick to anything that's wet at all. So if you're going to do that, use a product like CT1 that we use here at Gaslec. And it's like a silicone, but you can use it underwater and you can use it in wet environments, and it will create a seal when you put that back in. So it's not the most difficult thing, but if you do it as a DIYer or as a new person in the industry, just make sure you turn it on and you check it thoroughly. And then, that'll tell you if it's working or not. Okay, so that's the WC. So my hot water has stopped. So we've had a few of these this week. So I always ask the question, is there water physically coming out the tap, or is it just not hot anymore? So there's a couple of things. If you've got a combi boiler, you're running your hot tap and it's not firing up, is the boiler doing anything? Is it firing up as it usually would? Is it making a noise? Can you hear the fan running? Can you hear the pump running? Is there any little tap symbols on the front of the boiler that are illuminated or starting to flash? Is the boiler trying to do something, in other words? If you're running like a hot water cylinder, go up to your cylinder and the pipe coming out the top typically, is that hot? Now, if that's not hot, then you ain't got any hot water. So, and certainly if you've been trying to draw it off for more than about 5 seconds, because the water will rise up and come out of the pipe, and actually as the temperature of the water will rise and it will actually come out the top of the pipe anyway. You'll start to feel the heat rising up. But yeah, that's a really good way of testing. Just touch the top. So have you physically got water coming out the tap, or is it physically there's no water actually coming out of the tap at all? Now, it all depends on how you heat your hot water, whether you heat it via a boiler or whether you heat it electrically via like an immersion heater. A bit difficult to sort of go through that question here on a podcast, but really whoever your local and trusted plumbing and heating experts are that you use, I'd say give them a call in this situation, because you could be looking at an immersion heater that's rotten through, you could be looking at a thermostat, you could be looking at the cylinder stat, you could be looking at a 2-port valve switching issue, a 3-port valve switching issue, you could be looking at a boiler that's not firing up, you could be looking at a plate heat exchanger that's blocked, a boiler pump that's blocked. So there's quite a few factors involved in that question, unfortunately. Another one, which I've not really gone into, I don't think, before, is why are waste pipes different sizes? So there's a couple of things here to talk about. So we'll talk about our basic pipe sizes, which is our 30, our 40 and our 50, as we call it, just for round numbers. So if we're looking at just those as that first question there, so the basin waste will typically be in 30 mil. So that's the smaller of the three waste pipes. So 30 mil waste pipe off your basin, that will then take hand basin sort of volume and flow of water, which isn't a great deal, and it'll take it away. When you start looking at bath, showers, sink wastes, dishwasher, wash machine waste, then we go up to the 40 mil, which is a bigger diameter, which can handle more water as it flows through. Because obviously we've got waste pipes, typically they're not pumped, so we're using gravity to take away the water that we do. When we start looking at 50 mil, typically there's some different people when you talk to them about different things, but they say if you're running 40 mil pipe more than 3 meters, you need to increase the size of 50. But I'll take a bit of a view on this really and look at the household, how it's using its water and wastewater, what's going down, roughly sort of the times of day that it's going to be happening. But if you're bringing 40 mils together, let's just say, and you're in like a HMO where you could have somebody using a shower, somebody using a bath, somebody using a sink, and it's not one family, it's multiple people that could be doing it at different times, certainly I'll be putting up into 50 mil or the 2-inch, as then we start calling it, and taking that across, and that'll handle all this wastewater that's coming through. So the other side of this question I want to talk about, actually, when I say different sizes, it could mean we've got 2 sizes that we actually use. So our 30s in one type of waste pipe and 30 in another are actually different sizes. So we commonly call it glue, which is the one we put the adhesive round and we glue the fittings on. And they're a one-way item. Once you glue them in, that's it, it's finished. They bond, they vulcanize between the 2 surfaces. So it melts the first layer of the plastic on both surfaces, and it vulcanizes the both together. The other one is like a push fit system. Now, I'm not a big fan of these. They just push in and that's it, which means they can pull apart and that's it. So if you're going and doing some plumbing works, then I would say always use the glue system. The pipes are a bit more rigid, but they last a lot longer. The only downside I would say with glue pipe, with a bit of age, they can become a bit more brittle, where on the push fit side, they do stay a little bit more hardy, and I would say that for our waste pipe. There are other conversations about temperatures of water that it can handle because it's a different material, but we're just talking about wastewater here at this point. I'd say that if you're not confident about gluing the joints, they do compressions, so you can use our compression couplings and T's and elbows. They're a bit bigger and a bit more chunky, but they grip onto the pipe a lot more and a lot better than they do on the push fit system. And if you have got a push fit system and you've got a glue system, to bring them 2 together, you're going to need a compression coupling anyway, because the rubber on the compression will come down from our 30 mil basin waste. Our solvent outside diameter 30 mil is actually 34, I think it is, and that will squeeze down to the 30 mil. And on the 40 mil side, the outside diameter is 46 on solvent, which will then pull down to, I think, 42 onto the push fit waste. So potentially the conversation there of the push fit and of the glue systems. So shower cartridges, and this will be the last one I'll talk about on the questions. So shower cartridges and getting them changed are probably one of the hardest things here we do as plumbing here at Gaslec and across the board. Shower cartridges, certainly when you've got a concealed shower and it goes in the wall. So what you have to do is you have to go out to the job, turn the water off, drain it back, take all the fascia plates off, all the little knobs that have got the little secret Allen keys, get all of those, take the cartridge out, unscrew it, and then we have to measure it and photograph the shower cartridge. There are so many different cartridges available, and we don't know, unless we know the make and model of the shower, of what cartridge it needs to be. So then we do all of that, put it all back together again, turn the water back on, test it, go off, find the shower cartridge, and then purchase it, come back and do the same again to fit the new cartridge. So it's actually a really expensive system because there is so much labour involved in just changing the cartridge over, unless you know the make and model of the actual cartridge itself. So that ends the questions, and thank you very much indeed, guys, for letting them for asking those, and hopefully I've answered your questions there as well. So, should we switch the heating on in August? So, I know we're on the 26th of July. So, I've said it before. I've said it 20 times. I've said it across all my social. I've said it on podcasts. Yes, yes, and yes again. Every week or two, just turn your heating on briefly. Just run it for 5 minutes and then turn it back off. If you've got 3-port valves, diverters, whatever the system you've got that switches it over, it turns the pumps on, gets the water circulating, and just make sure that things are moving forwards. Now, yes, it will burn a bit of gas, it will cost you a bit of money, but trust me on this one, that the amount of calls we get for no heating when it comes to the first cold snap in August, it really does help with the bank account. Let's just say that. We are so busy doing it all and everybody is flat out. So just be mindful. If you want to save yourself a couple of quid this autumn, fire up your heating system every week or two and just get that stuff circulating. And that will be the biggest lesson and tip that I can give you onto that. So, plumbing items, here we go. So, TMVs. So we use these all the time here at Gaslec. We do some commercial works, and we work in children's nurseries, working some care homes, working some churches, work in doctors' surgeries. And some other bits and pieces as well. Off the top of my head, I can't think. So there's a couple of things we've got. So one of the things that we get through a lot of, and certainly leisure centres as well, is TMVs, thermostatic mixing valves, or blending valves as they're called. And they're really, really straightforward. They've even got 2 colour dots on, and if you're colourblind, it's got an H and a C written on it as well. So what these do is, if we're storing hot water in these commercial buildings, we'll have like an unvented hot water cylinder. We may be having the water at 65 degrees, 70 degrees, 75 degrees, 80 degrees of hot water. And what we can't have is people that are residents, children, the elderly. And if you're in an environment where you don't know the people that are coming into, like a doctor's surgery, in a waiting room, and you got a toilet off to the side, you don't know who's going to be coming in, whether they've got any additional needs, any challenges. So you need to limit the temperature of your hot water as it comes in. Now, these don't apply to commercial kitchens or your kitchen area where you need hot water for washing and cleaning. It doesn't apply to utility rooms. If you've got some sort of janitorial sinks, we're going to need hot water for mopping floors and stuff like that. And if you've got staff members, you need to make sure you put up that caution hot water sign as well. But anyway, that's going through that. So this is a TMV. So what happens is, onto here, the hot will come into one side and the cold will go into the other. And out of this bottom piece here is what we call our blended water. Now, into these sides, what we do have, and sometimes we get callbacks on these, is that, I don't know if you can see that on the inside there, there's like a mesh gauze, and that is a non-return valve. Okay, so sometimes these things can go wrong. We can get a little bit of rubbish that creeps up into them, and then they can block and go wrong. Underneath here is our Allen key, and this is where we adjust and set the temperature of our blended hot water out. Now, different environments need different temperatures. Like if you've got a children's nursery where you've got 2, 3, 4, 5-year-olds using the hot water, we don't want that much more than skin temperature. So we want that around that 37, 38 degree mark. So it's about skin temperature as they're washing their hands or doing whatever they're doing. We then start looking at going into places like a care home. I think the maximum temperature there is about 41. So it feels, fairly warm to the touch, but it's not going to hurt or injure anybody. We'll also see these, we don't do new builds, but you'll see these on baths, underneath baths. And some people do call us up about getting these removed. On the... obviously, down to water regulations, what you don't want to do is, because once again, the house builders don't know who's going to be moving in. You run a really hot bath of pure hot water, that's getting in for sort of 60 degrees. You climb in it, slip over, get fully submerged, can't get out like a spider, and before you know it, you've gone into cardiac arrest, and that's you done. And slowly cooking as well. There's some tragic stories around the country and around the world of that happening. So they'll fit these blending valves, TMVs, underneath. So on the blending valves, there's two types. There's the TMV2 and TMV3. So the TMV2 will be your under your bath and your sort of children's nurseries, that sort of environment. TMV3s, and we only really fit TMV3s, they'll do that, and they'll also be more for hospitals and for care facilities as well, so for a lot more stricter. So the tolerances of the manufacture of these things are a lot better. So we only fit TMV3s. There's no point in messing around for the extra pound or whatever it is. When you're actually buying the whole thing, you might as well just get the better quality one to start with before we go. So we've now got the pressure reducing valve. I thought I just found one downstairs. So this is a little 15mm fella. So it doesn't have a PRV on it. It doesn't have any sort of other takeoffs. So it's cold water in, yeah, and there's an arrow on there as well. So really sort of self-explanatory. Cold water in this side, cold water out that side. And on the top, it says there on a sticker, it's been set to 3 bar maximum, but it is adjustable. So for whatever reason, if you wanted to adjust it, and it's got a pressure gauge on there, so it can help you set your static pressure, and that's what you'll have. And typically, if you've got if you're on like a new build where they put some brand new water pipes in into your system, into the installation of your wherever you're living, you can have some really high pressures coming in. So these are an absolute must as they come through. And what this will do, it will reduce the pressure to a maximum of 3 bar as this one's set. So everything downstream to your house will be on a reduced pressure, because what you don't want to do is have a massive spike in the middle of the night, rockets up to 10 bar, and the first weak point of your house just goes pop and then leaks everywhere. So yeah, and that is a pressure reducing valve, quite a little simple one really. Sometimes they have little PRVs on them, little takeoffs and stuff, but this one hasn't. So I don't know why we got a 15, normally 22, but anyway. So that's that on those bits there. I want to show you these here. These are some electrical back boxes. So there's a lovely little electrical factors called Priority Electrical Factors that we use in Gillingham. A little sort of independent run, fantastic service up on Gillingham Business Park. I'll always sing old Simon and the team's praises up there. They've been around for a long, long time. But they do these little boxes. Now these are just like a normal Patris box for your electrical, a little surface box, like any other. But these are, and I don't know if how I'm going to show you this, but they are flexible. I don't know if the camera can see that. So you can have a bit of a twist to them and a bit of a flex, and they don't shatter like the cheap ones you get from like your Screwfix. So when you put your drill in and you drill it to the wall and it's not quite 100%, it won't shatter. It will twist and it will flex with it. So not a lot more, about £1.50 for the box. But you can throw it in your van and you know it ain't going to get smashed up. The downside is the knockouts, what you normally do with the cheap rubbish, you can't do. You've got to drill this out. I think there's a little tap out on the bottom of that one in there. I don't know if you can see it. And it's got like a 20mm sort of gland thing ready to knock out there. But typically we'll get these drilled. So, so what have we got up to? So we got a new marina on board last week here at Gaslec. So we got called out to a marina. We ended up fitting a boiler last week, and I did it myself. It was a 1 kilometre walk from the vessel down on the pontoon all the way up to the car park. Unfortunately, I had my little festival trolley, which was absolutely amazing. And I got everything down onto that trolley, which was a godsend. It was such a long, long way, backwards and forwards each time to the van. But we got that on board, and they had this little floating pod thing. So we'd done a gas safety check on that, all went lovely. But somebody had used like a John Gee speed fitting pipe work, which isn't a problem. We use this sort of stuff ourselves, but they use the double seal insert. Now the double seal insert they put on the top of the pipe, which is correct to stop the pipe from compressing, but it went into an isolation valve. Now typically isolation valves are very shallow in their sort of the amount of pipe you can put in, and they're really ideally suited for copper pipe. But that meant when the olive went on, it was right on the tip. So we got the water heater up and running. Wasn't running that well, and I turned on the tap, running at 42 degrees, so it wasn't even that hot. And then I was outside doing some bits, and I heard water running. This pod thing was sort of run off a hose pipe, which ain't great because it wasn't sort of water regs approved. But anyway, it's another conversation for another day. And then we started having a flood inside. Fortunately, I was there, turned the water off, and then found what the issues were, and then changed the inserts over to the metal insert, which has got a shallower sort of face to the top of it. So the pipe went in, which meant the olive went further down the pipe properly, and then made a grip onto that. And it's just disappointing because it was only the week before that another plumber on the area had actually gone out and fixed it. And when I actually come back with the fittings, he was standing there. So I just told him what I thought. So maybe a little bit unprofessional there, but it was a Friday evening. I was late going out with the wife, Mrs. Gaslec, and he's eaten into my time through overlooking or being neglectful. So there was damage to the property, which was nothing to do with me, which is now being picked up by the lady there. So there we are. So that was last week. We've done some air conditioning stuff as well last week. We've done an install on Friday. This is Saturday the 26th. So we got that done yesterday by the team, which was awesome and fantastic. We got some, so next week we've got some staff holidays that are coming up, which is always lovely because I really enjoy when people come back off their holidays and they've had that time of reflection and all refreshed out, and they come back to work and we get their stories of how wonderful their experiences have been with their families, been away. And genuinely, I do like that. Yes, it's a bit more pressure and a bit more work for us here, and certainly for myself. But the staff getting their R&R is really, really, really important. They come back, and I see it all the time, and they've got that an extra boost of energy and enthusiasm. So yeah, and we got some bits on next week, but obviously a little bit on the reduced because of the staff holidays. So yeah, there we are. Well, thank you very much indeed for listening. I've rattled on for getting on for about 36 minutes. So thank you very much indeed for bearing with us on this episode. If you've got any questions at all, email us at podcast@gaslec.net. If you are local to Kent or the southeast and you've got a question, you want us to pop out and to take a look at anything in your domestic or commercial setting, give us a shout at office@gaslec.net and we'll be happy to help. You take care, folks. Have a fantastic week. Goodbye.